Hi, I'm Paul Dvorak, editor of Wind Power Engineering and Development magazine. Today, we discuss how a conventional wind turbine works. This is a model of a conventional turbine, often referred to as a horizontal axis wind turbine. That means its drivetrain, the rotor, the main shaft, a gearbox, and the generator are all pretty much in a horizontal line. Now let's go inside the nacelle and see what each component does. We'll start with the rotor, conventionally 3 blades. The blades essentially catch the moving air and turn it into rotary motion. Each blade has an airfoil cross-section, much like an airplane wing. Lift on the blade causes rotation. A useful rotation speed for a turbine is about 5 to 15 RPM. Here's the main bearing that supports the rotor and lets the main shaft turn. It's like a huge ball bearing, about 6 feet in diameter. Now, as you might imagine, there's not a lot of speed to the main shaft, 12 to 20 RPM on the high side. But the torque, the amount of twist, is enormous, many pounds-feet. A common 4-cylinder engine, an automobile engine, might have 150 pounds-feet of torque. But the wind turbine shaft, for a common 1.5 megawatt wind turbine working at capacity, would transmit about 700,000 foot-pounds of torque. But at that speed, 15 RPM, it's not too useful. A conventional induction generator needs about 1,000 RPM to produce useful electrical power. So our turbine has a gearbox that can handle that huge torque and turn the 15 RPM from the main shaft into something close to 1,000 RPM. So at the back of the gearbox, a high-speed shaft connects to the generator through a coupling. This connection space also holds a disc brake that functions just like the disc brake in your car. The brake is needed because when some event happens that might damage the turbine, say a fast-approaching storm, the operator can send a signal to the turbine to halt the production. When this brake engages, it brings the rotor, the gearbox, the generator to a halt, and it holds it there until the controls signal that the turbine's safe to start again. Now, if we walk a little bit farther back the nacelle, we come to the generator. Most land-based wind turbines use induction generators. That simply means there are 2 sets of coils, one that turns and one that is stationary. Now, that action produces electric current. For more videos that explore wind turbine design, visit www.windpowerengineering.com.